Okay, good afternoon, everybody. Thanks for coming to our session. My name's Ant Ducker. I'm a global security architect at Cisco. And today we're going to talk a bit about going beyond microsegmentation with some of the innovations that are coming out with Cisco, specifically Cisco Hypershield, which is what we're going to talk about today. You have to bear with me. I'm normally a bit of a pacer, but I'm not used to this kind of stuff going on, so I'm just going to have to work around it. So to begin with, what we want to think about is really where we are in terms of cybersecurity basics in these modern times. And they were tough to begin with, but they're certainly tougher today, and that's driven by a few different factors. The first factor is really the proliferation of APTs, or Advanced Persistent Threat Actors. The level of sophistication that we're seeing through the level of funding that they have is unprecedented. And these Advanced Persistent Threat Actors are really focusing on looking for previously unknown, previously undocumented vulnerabilities. This is the kind of bread and butter for those. They're able to use those things to deliver more sophisticated tooling in the form of malware and advanced malware into our environments. One of the other problems that we've got there is that advanced tooling is also in the hands of the less sophisticated threat actors, usually by being sold to the less sophisticated threat actors in the forms of things like ransomware as a service, that kind of thing. So we're being attacked from kind of differing levels of sophistication in terms of the threat actors, but those threat actors are using highly sophisticated tooling. We also see a lot of change in our environment, far more change than we've ever seen before in the data center. At Cisco, when we talk about the data center, we mean both public and private cloud, because typically that's what we see today. So, you know, we've got all of these challenges, and things are only going to get tougher in terms of cyber defense, so we need a way of dealing with that. We need some help in dealing with that. Some of the, I guess, fundamentals are still elusive to us, you know, the kind of building blocks for cyber defense within our data center. Those fundamentals being segmentation, patching, and change. When we think about segmentation, it was challenging to begin with, even if we started with things like zonal segmentation. Certainly if we think about extending that into application and microsegmentation, it's difficult and it's getting harder because we're seeing explosive growth in the workloads. Think about things like modern apps where we're spinning up pods and containers left, right, and center. It's really difficult for us to keep track of that, which means it's difficult for us to have consistent enforcement across those applications within our data center. And the environments themselves keep changing. We're adding, you know, sections of the data center, farming bits of it out to hyperscalers, those types of things. But it's fundamentally required. You know, segmentation, even zonal segmentation, gives us some regulatory requirement points, but also things like containment. If I've got distinct security zones in my data center, if and when I get breached, I've got a level of containment for that. So it's a necessary. The second part, surprise, surprise, is that patching is hard. And again, we're seeing a high rate of vulnerabilities, and this is driven by those advanced persistent threat actors who are looking for these vulnerabilities, looking to exploit them. Also in part driven by security researchers like me, sorry for that, because there's an incentive for security researchers to go and find these vulnerabilities. So anybody who keeps track of CVEs, common vulnerabilities and exposures, will have seen a huge spike over the past few years in new and exotic CVEs that are coming in. So we've got more of a bigger attack surface that we need to deal with. The mitigation part is the difficult part because we know that we have to patch, right? That's the solution to these vulnerabilities. But in order to patch, we have to identify what the vulnerability is, what our exposure to that vulnerability is, where in our environment we need to start, how we prioritize it, and then we need to go and test it and make sure that we're not influencing applications or breaking the environment in any way by implementing these patches. What we tend to do is, while we're thinking about that kind of testing cycle, we say, well, maybe we can implement some compensating controls to reduce our risk exposure, but we run into the same or similar challenges. I still need to test out those compensating controls. I'll still need to validate that they're not going to break the availability of my application. So this is becoming a hard job for us. And then finally, change is risky and expensive for a couple of different reasons. I've certainly seen this in my career. I've worked in network and cybersecurity for 20 plus years. The number one cause of network outages in network environments that I've been working in is change that we've deliberately made to the environment that wasn't validated or verified in the correct way. This drives much more scrutiny on changes. We have these things like change advisory boards, those types of things, which delays our ability to get these changes out onto the environment quickly. The knock-on effect of that is maybe we have critical firmware updates that need to be implemented. Maybe we've got security policy changes that we need to make. These are going to delay our target candidate security posture because of this delay in testing. So we're always going to be a bit behind the curve in terms of our security posture. The other part of that expense, of course, is one solution that you can try is to replicate the entire environment in a test or a dev environment and do it that way. And that's a very expensive option and not always representative of what's happening in the production environment. So these are the kind of challenges that we're faced with, these basic challenges, and these are the things that we're looking to solve with Hypershield. Now, Hypershield is part of the overall Cisco Security Cloud. In Cisco Security Cloud, you can see we've got a number of protection suites available. The name kind of suggests what they do. We've got breach protection, user protection, and cloud protection. All of these suites, all of these capabilities are backed with pervasive firewall capability, so security capability underneath. And all of these are empowered with identity intelligence, so we can leverage identity intelligence both for policy and for identifying if and when bad things are happening in our environment. As well as that, we have, surprise, surprise, AI. We're using AI in a number of different ways. We're using AI in a kind of a chatbot or AI assistance method, using large language models to assist us in various aspects. We'll talk about that in a bit more detail later. But we're also using AI in a predictive way, right? We're building neural networks. We're using telemetry from what we see inside of the Cisco Security Suites portfolio and beyond to feed and train neural networks to give us AI assistance, augment our workflows, and actually help us predict what might happen and how we can deal with that. And that's really where Cisco Hypershield comes in. So Hypershield is a distributed AI native solution. Hypershield is not a new iteration of something. Hypershield is completely new. We couldn't have built Hypershield without AI. Hypershield is managed in Cisco Security Cloud. We'll talk a little bit about Cisco Security Cloud Control in a few moments. And our GA use cases really are autonomous segmentation and distributed exploit protection. And these are geared around these exact challenges that we've spoken about. You know, these challenges of how do we keep track of what's going on in the data center? How do we effectively segment things in our data center? And how do we deal with all these exploits that are vulnerable, or we're vulnerable to, inside of our data center? So we have AI-driven workflows that are supporting these two use cases. The platform itself, as I said, is AI native. We have enforcement and visibility capabilities from the kernel level, that's a Linux kernel level, right across the stack, so network transit points, switch ports, that kind of thing. And we're leveraging a technology which we'll speak about later called dual data plane, which allows Hypershield to even qualify updates, even qualify software changes or policy changes, I should say, before they see the light of day, before they get into production. We've got workload and enforcement points across both public and private cloud, and we'll talk a little bit more about those as we go through. So Cisco are kind of uniquely positioned really to what we call blend security capabilities into the fabric of the network, and that's precisely what Hypershield aims to do. Rather than have these kind of distinct security devices that come in a box and we put them on the edge and in the middle and all around our data center, Hypershield is actually leveraging parts of the network as security fabric, and we can cover that at all areas of the stack, whether that's public cloud, cloud native services, which is going to be more kernel-based coverage, or if it's in private cloud, so think DPU-enabled switches, DPUs inside of servers, virtual enforcement points, those types of things. These are simply enforcement capabilities that are available to Hypershield, and Hypershield's going to leverage those in visibility and then aiding us in terms of suggesting or recommending security policies. So a bit more about Hypershield. It is a truly cloud-native, unified managed solution with a single global policy. And what that really means is, as and when Hypershield recommends policy, or maybe you define your own policy, that policy is compiled in the right place into a single global policy. The policy engine itself spans not only the traditional 4 or 5 tuple network-based controls, but it includes process level controls as well. So we can actually do a combination of all of those things in that unified policy. As I mentioned before, Hypershield treats the security fabric as just that. So it abstracts away this idea of policy installation targets. Again, if I think back to my career when I was doing firewall changes in a very large global universal bank, we would think about policy changes and think, well, what are my policy installation targets? Where do I need to actually push this in order for the policy to be successful? That's abstracted away from the operator here. Hypershield just says, well, you've told me what the policy is. I know what enforcement points I have available to me. I'll just put the policy in the right place. I'll tell you where I'm going to put it, but I can decide that for you because I know what available enforcement points I have. At GA, the enforcement points we have available are a combination of end-user system enforcers and network-based enforcers. The Tesseract security agent we'll speak about in a couple of slides is covering Linux workloads and Kubernetes nodes. And very shortly, we'll cover Windows servers as well. This is reliant on Windows releasing support of a thing called eBPF, and I'll explain that in a minute. And the network-based enforcement points, right now we have a virtual machine appliance enforcement point, and very soon we're going to be able to provide network switch ports, so hyper switches, which are DPU enabled, which will allow us to treat every switch port as an enforcement point, and then DPU NICs on a server where the NIC is inside of the server, and we can program the DPU and use that as enforcement for anything that lives on that server. I mentioned security cloud control, and really the vision of security cloud control is to truly unify all of the products inside of the Cisco security portfolio. And we don't just mean, well, you can go there and launch the individual UIs for each of the things, right? We mean unified. So we're talking about coordinated security solutions, consistent enforcement, shared objects. Everything happens in security cloud control, and that's not just limited to what we can do in terms of operations. Remember, we've got machine learning behind the scenes here. We've got neural networks that all of a sudden we can train with telemetry across all of these things. So this is really a starting point and a central place where we can drive all of our security solutions augmented with the power of machine learning. We're also going to extend that as well to third-party firewalls and third-party enforcement points, again, to extend that unified and consistent policy across the entire stack. So as an example, this is what security cloud control looks like now. We can see that we have insights into things like policy optimization. You know, Hypershield, or rather security cloud control, can figure out opportunities where security policies can be optimized, whether that's for performance, whether that's for regulatory, or whether that's for something else. Also, Hypershield has this forward-looking capability using the neural networks, this predictive nature to say, well, if we don't take some action, this is what's going to happen. So this is a recommended action that we want to take. And this is true for all of the Cisco security portfolio products. So the idea of these three kind of bullet points at the side here is to simplify the operations with this centralized control, enhance security, these AI-driven and AI-augmented workflows, and increase efficiency. And it sounds like a bold claim, but we honestly believe that we think 90% of tasks are going to be eliminated, 90% of manual tasks will be eliminated by leveraging AI and neural networks in this way. So I've spoken about the Tesseract security agent a bit, and I've mentioned the magic words eBPF a bit already. Anybody here heard of eBPF? Nobody? Okay, cool. So eBPF stands for Extended Berkeley Packet Filter. It's not the most amazing name, but it is a very amazing technology. eBPF is something that's native to the Linux kernel, and eBPF is a safe placeholder in the Linux kernel that allows us to interact with things at the kernel level of the operating system, take telemetry from the operating system, but crucially send control instructions via eBPF to the operating system as well. So it's extremely performant and extremely safe way of controlling currently Linux and Kubernetes-based workloads at the heart of the operating system, basically. As I mentioned, not available for Windows today. Microsoft are currently developing that at the moment, and we expect that to be released shortly for Windows Server initially. So what does it mean really, right? Let's think about it. If we understand the Linux kernel or the kernel of any operating system, everything has to traverse the kernel. Absolutely everything must touch the kernel, which means eBPF gives us visibility on process activity, network socket activity, storage, device I/O, everything, because it's all traversing the kernel. Now we can take this data and we can feed this data back via Hypershield into neural networks and train those neural networks in a way that we've never been able to do before on how the application is working, let alone the operating system. If the operating system's supporting an application, we get to see that too. We've got namespaces up here, so if that operating system happens to be running part of a Kubernetes cluster, guess what? We see the namespaces, we see the pods, we see absolutely everything. So now we can train neural networks in a very minute and granular way. This is precisely how the application's working, not just at a network level, but a process level, and then the context between the process and the network and the storage, everything, right? Very, very granular visibility, which gives us the opportunity of very, very granular control over time as we observe how applications are working and how applications are behaving. Now, self-qualifying updates, I mentioned that earlier on, and there's really two use cases for self-qualifying updates. That's with a firmware, or let's say an operating system update for an enforcement point itself, or a policy update. If I want to make a policy update or a policy change, this is what I want self-qualifying updates for. In Hypershield, the network enforcement points have this concept of a dual data plane. So there's a secondary data plane, a shadow data plane, that gets spun up. And in that shadow data plane, we're sending a copy of all of the production traffic down that secondary data plane. Inside of that secondary data plane, we're running either the candidate new security policy or the candidate firmware or software upgrade. And we're evaluating what happens when we test that with this new policy or with this new software update. We can automatically approve almost everything, right, in terms of the rollout of this update, leveraging AI and leveraging machine learning, because we're able to validate and give you assurance that this is what's going to happen if you actually do this, if you actually put this into production. But we do realize that we need to earn your trust, or rather Hypershield, artificial intelligence, machine learning needs to earn your trust, which is why there's an approval process that still needs to happen from a human being, right, to look at the changes and look at the tests that have been done by Hypershield and actually validate and verify that you're happy with that. Hypershield will give an overall confidence rating of all of that automatic testing with a threshold of 95%. That confidence testing includes, I guess, as you would expect from Cisco, do I influence packet flow in any way? Do I see an increase in dropped frames? Do I see an increase in latency? Are there huge differences in the way that the security policy works? So we're taking all of those inputs into the neural network and we're deriving a confidence score. Yes, this is how successful this change is going to be if you decide to roll it out into production. Behind the scenes, obviously, there's a complete test journal. So you've got the ability to go and look at that test journal, look at which enforcement points it's going to touch, and actually look at those tests in detail if you want to. And we imagine that you will want to until, you know, we've earned a bit of trust here about what we're doing and how we're doing it. So the two main use cases that I spoke about earlier on, autonomous segmentation. Now think about the capabilities that we've got from Hypershield, this deep understanding of application behavior right down at the kernel level, in addition to other inputs, you know, from network telemetry, maybe switch port telemetry. So we've got some very, I'd say, unprecedented levels of telemetry for the application to feed in to autonomous segmentation neural networks. We can also identify applications that are changing, and we can differentiate, as we'll see, between legitimate change and suspicious change. The second use case is distributed exploit protection. Again, I have to be really clear. You have to patch, right? Whatever it is, you have to patch, and we're not saying otherwise. But distributed exploit protection is helping us out by streamlining the process, closing that gap of exposure by helping us identify and prioritize, but also to provide surgical mitigating controls, controls that are designed to disrupt the threat, but not disrupt the application. So let's talk about segmentation first. In autonomous segmentation, using those inputs, Hypershield will start to build up a picture of the way that the application works. As we mentioned before, not only distinct application components, but how the application is working at the process level as well. And as Hypershield starts to learn the behavior of that application, you'll start getting policy recommendations. Hypershield will say, hey, we've seen that you've got a finance app. There's no segmentation here at all. maybe we should start with some basic zonal kind of guardrail segmentation policies based on the application's behavior. And as and when the application behavior changes, then you'll get more and more recommendations to say, actually, we've got an opportunity to make this segmentation tighter and tighter and tighter. There is no default drop on this policy. This is an explicit policy that's being recommended. And the reason for that is, this is a life cycle process, right? Spoiler alert, segmentation isn't something that you can just do and then you're done, right? This changes over time, and that's part of the reason why. Hypershield has the ability to relax these segmentation rules based on legitimate application behavior, relearn, refactor, and then again start recommending new and lower segmentation policies. But as I mentioned, if there is let's say a suspicious or malicious change, Hypershield can identify that as well. This is obviously a very basic example, but hey, your database is now starting to try and initiate connections to your front end. That is not good. That should never happen. The recommendation is you should block that almost immediately, right? So there's this distinguish between legitimate change and either malicious or suspicious change, and Hypershield can react to both of those things. And then with exploit protection, this is where we're aiming to close the exploit gap against vulnerabilities. Going back to what I spoke about earlier on, right? Kind of gone are the days where I need to focus on my inbox for CVEs and then start to figure out how do I operate on these CVEs? What do I do next? The first you'll hear of it actually is Hypershield's workflow will say, hey, we found a new CVE. It's a high priority CVE. This is a container escape vulnerability, and we prioritized it for you. We prioritized it based on the Cisco Talos criticality rating. We've also given an independent rating in the form of a CVSS score, and we've also identified assets on the network that are vulnerable to this. But we've gone a bit further than that as well to say, out of all of those assets, these are the most critical ones. This is where we should start. So we've identified where it is, we prioritized it, and we've actually built a workflow to give us compensating controls to deal with this. By the time you've seen this, it will actually already been tested in the dual data plane. And the target test is actually very targeted installation. In this case, this is with the Tesseract security agent to disrupt the threat, not disrupt the workload. So actually, the exploit protection shield in this case is bound to the run C binary, the vulnerable binary, and will only become active if that run C binary attempts a container escape. So it's extremely targeted, as I said, designed to disrupt the threat but keep the application running. And of course, we've tested it already, right? Similar idea for the dual data plane for segmentation. We've tested the basics, right? Does it cause us increased latency? Does it cause wild differences in our policy drops or policy allows, those types of things? But crucially, in this workflow, there's another test to say, does it actually work, right? So again, we're using the shadow data plane to send the exploit down the shadow data plane and actually verify that that protection shield does what we intended it to do. So two very important tests in the case of distributed exploit protection. And of course, if and when the workload is patched or the container is patched or whatever it is, Hypershield will know and be able to suggest or remove that exploit protection shield. So it's a way of policy lifecycle management for these exploit protection rules. Obviously, this is designed to buy us time, right? To limit our risk exposure, to give our application teams time to go and properly test that patch, make sure that it's not going to cause us any problems. So it's a very smart way of doing that for us. So really, the idea of Hypershield is to deliver business outcomes. So we've seen things like accelerated security protection in the form of distributed exploit protection, higher security efficacy, and that in part is linked to security cloud control, using these neural networks to help us drive segmentation, autonomous segmentation, and wider operations activities inside of our data center to reduce outage downtime because we're testing everything before it actually gets into production. I imagine I'm extremely jealous, by the way, because I wish in my day I'd been able to go to the change board and say, I've tested it, here's proof, you know, it's done. And that's what it's designed for here. And lower the barrier to expertise. So we're using AI, we're using neural networks and machine learning to actually help upskill our operators and help them drive better security for the data center. So we'd love you to get started. We'd love you to see more about Hypershield. There's a QR code here that you can scan if you'd like to hear more. We're really interested, in particular, in if you're interested in one or other use case, or whether it's both use cases, and we'd love to share more information about it. We are here. I don't know if we've got a number for our booth, but you'll find us. Just look for Cisco. We'd be more than happy to talk to you. And I think I've got 5 minutes left. So if there are any questions in the room that you want to shout out now, absolutely happy to take them.